code, assemble code here. Okay, let's start. This part is my actually initializing part. I will introduce them briefly. This part is for stack initialization, and this part is the port initialization. We use in this project port B as input, so I set them as 0 to make it input. And for port A, it is also output. It is an output, so I set it as FF 111 actually. And for port C, we use only three digits of port C. For pin 0, it is connected to LCD with RS command, pin command, and for pin 1, it is connected to RW. Sorry. I will explain meanings of them in the next part. And for pin 2, it is connected to EN on the LCD. In here, we initially set them to EN off because it is for reading a data, so it must be initially off. We on it when it is necessary. So after that, we call a delay 2 microseconds. And this is for LCD initialization. 36 at 38, it is for initializing 2 lines LCD command. And after that, we call command write and we process it. LCD commands table is here, so I use here. And after that, we have to on the display and cursor. We call this command. And after that, of course, we have to clear the LCD. So we use clear display screen code 1. And after that, I call delay. After each command write, I always use delay 2 microseconds. And this is actually our main code, the loop actually. At the start, in our system, we get a data from switch and we connect them to port B. So we get data from port B and I set it to R24. And for using in the next part, I use the temperature registers, set them there. And in our case, switch sends the 8-bit data, and the low part of that data is 0 to 3. It actually represents temperature, and the high part of that is 4 to 7 is represents the water. So we have to separate them and use them accordingly. So I use and get the low part of that temperature, and only for water level I use high part. And of course I have to swap R16 26 because it is up to 0 to must be 0 to 16. Then I swap it. It is necessary. And after that, we are ready for writing. And no, actually, we have to clear LCD again. And after that, we have to set the cursor the beginning of the line for writing data. And it's our if line's first position is 80, then I set it to 80. And after that, we are ready for writing. As a template, we have to use temp. We have to display it to the LCD. I did it. And after that, we have to check if our temperature is, what's this? We have to check if our temperature is valid or not. If it is greater than 5, it's not valid. So we check by this line. If this part is true, it executes temperature not done. And in temperature not done, we are displaying to LCD. Where is it? We are displaying to LCD error message. But if this is valid, we are displaying the data that we get from switches. So we did it in here. But of course, the data we get it is not a ASCII character. So for converting it to ASCII character, we have to add it with 30 because ASCII characters start with 30. 30 is 0, 31 is 1. It goes like that. So adding is enough with 30. After that, we have an ASCII character. Then we write directly this data. After that, we, as a template, degrees Celsius, we write it them. After that, for temperature, we are done. We go to temp done. And we have to go to second line. So we set the cursor, this command, set the cursor second line. And for that, we have to, first starting point is 80. And after 40, it goes to second line. So we add them and set it to R16 and send this command. And now we are in the second line, starting point of the second line. And as a template, we display water. And after that, we check validity of water. If it is greater than 9, it is invalid. So if it is true, we go water not done and display error. If it is not, we go this line, turn it into ASCII character and write to this and display to screen and tone part as a template. And after the water done, we wait 10 seconds before the reading another data from switches with pin B. And we have command write, data write parts. Actually, they are almost same, but the main difference is RS part. RS is for choose or command, or is it command or data? Is it for it? And RV, actually I said probably RV is for RS is connected to port C 0 pin, 1 pin and 2 pin. RV is for writing. If it is 0, we are writing. And most important part actually, EN is tell the Yeah, load the rate now. No, else N is actually tell the LCD to read now. And after that we have to close it, be used temporarily. After that we call S delay, it's a fast delay. And port C, we close it by CVI. And we call hundreds microseconds. It's same as the data rate, but difference is, as I said, RS must be equal 1, so use CVI. In delay 2 microseconds, it's a actually loop delay, simple. 20 times call this, and when we multiple with this, it's equal to 2 microseconds, milliseconds, sorry. And for delay 100 microseconds, we use it. As delay, as I said, is a simple delay. And for delay 10 seconds, it's a 8 megahertz. And actually, it's a loop as well. And my code is like this. I go to circuit part. Let's start it. Okay, I started. Okay, first case, or I will first case is valid. So I select randomly. This part is temperature. This part's high water level. I set it to 4 and 2. Yes, it's correct. So let's make temperature invalid, sorry. Let's make it error, okay. Invalid part, we send it to 8. So 8, it's bigger than 5. So it displays error. It's working. So let's making valid and invalid to water level. I send it 12, sorry. And 12 is greater than 9. So it's error, again, true. So let's make both of them error, invalid. Yes, I send it 8. I send it 14 for temperature, error. I send it 12 for water, and it's also error. And my circuit is like this. For RS, RW, AN is connected to port C, like this. Thank you for watching.